Inside your brain, right now, could be millions of cat-borne parasites, and this parasite can control your mind. It has already infected between 1/3 and 1/2 of all humans on Earth. This parasite is called Toxoplasma gondii. It is a protozoan, a single-celled organism, and crucially, can only reproduce in the intestines of cats. This makes cats what is known as a definitive host. Every other warm-blooded animal, including humans, is an intermediate host. We can pass the parasite on, but our bodies do not have the right conditions for it to reproduce. Instead, it multiplies by cloning itself, a process called asexual reproduction. This life cycle pattern is similar to that of several other parasites. For example, in the case of tapeworms, canids like wolves, dogs, and foxes are the definitive hosts, where the adult worm matures and reproduces. For the malaria parasite, it's the female Anopheles mosquito. Humans and other warm-blooded animals are only the intermediary hosts to these parasites. If a rodent becomes an intermediary host to Toxoplasma gondii, something very interesting happens. Because the parasite can cross the blood-brain barrier in animals it infects, it is capable of changing behaviour. Infected mice and rats lose their instinctive fear of cats. Some even seem attracted to the smell of cat urine, which they would normally avoid, as do I for that matter. Behaviour relating to other animal urine, such as that of dogs, is unaffected, suggesting that this behaviour is a product of the parasite's manipulation rather than an unintended side effect of toxoplasmosis. The alteration in behaviour makes the rodent more likely to be eaten by a cat, which in turn allows the parasite to return to its definitive host and start the cycle again. This, needless to say, is not a great survival strategy from the perspective of the rodent, but for the parasite it's perfect. Through altering the rodent's behaviour, it increases the likelihood it can reproduce in the only place it can, a cat. It is also important to highlight that not all cats carry Toxoplasma gondii. This is especially true for many indoor cats, who have less opportunities to come into contact with the source of the parasite. Cats usually get infected by eating raw meat, typically prey animals like rodents and birds, that are carrying the parasite. More rarely, they can also ingest contaminated soil or food. Once infected, a cat will typically shed the parasite's eggs in its feces, but only for a short window, usually just 1 to 3 weeks after their first infection, and during this period, they can shed millions of eggs into the environment. These eggs are extremely resilient. They can survive in soil or water for months, sometimes over a year, waiting to be ingested by their next host. If a cat does get infected, it is often asymptomatic. Only kittens and cats with weakened immune systems are at risk of developing symptoms. Symptoms in cats can include fever, loss of appetite, lethargy, and in more serious cases, inflammation of the lungs, liver, or brain, which can lead to seizures, muscle tremors, or difficulty breathing. The source of infection in humans is somewhat different from cats. You're statistically more likely to catch toxoplasmosis from gardening in contaminated soil, eating unwashed fruits and vegetables, drinking untreated water, or eating undercooked meat from infected animals. That last one is especially common. Many of the animals we eat can carry the parasite, and cooking meat properly is one of the simplest ways to reduce the risk. Rarer methods of transmission include organ transplants and blood transfusions from infected individuals. In 2023, researchers demonstrated sexual transmission in mice. Whether this occurs in humans is still under investigation, but the possibility does exist. Infection in humans is of particular concern to pregnant women, because becoming infected just before or during pregnancy can pass the parasite on to the child. Most infants who contract toxoplasma in utero show no symptoms at birth. However, many will develop symptoms later on in life, including vision loss, developmental delays, and seizures. It has also been found that mothers of children with Down syndrome have an extremely high prevalence of toxoplasmosis. This is why pregnant women are often advised to avoid handling cat litter, to wear gloves while gardening, and to avoid undercooked meat. With all of that out of the way, how exactly does it affect our behaviour? Obviously, we do not have to worry about our cat eating us, although sometimes I suspect they would if they could, so we can rule that out. Research into the behavioural effects on humans has only really taken off in the last decade or so the picture is not entirely clear, but what we have been able to find out has been surprising to say the least. Infection, in some cases, could actually benefit us in some ways. One of the most well-established effects of Toxoplasma gondii is its effect on testosterone production in humans. A systematic review of 19 studies measuring testosterone levels in infected and non-infected individuals found that of those 19 studies, 13 reported higher testosterone levels in infected individuals. The others either showed no change, and a few even found reductions. So it seems, generally speaking, that infection raises testosterone levels. However, just under a third of the studies did not find this. Why could this be? It could be the case that in the early stages, immune activation may even suppress testosterone, with levels rising later as the parasite establishes itself in its host. If this is indeed the case, it would suggest that toxoplasmosis influences human personality, rather than human personality influencing the probability of infection. If testosterone levels vary depending on what stage of infection the host is, it implies that the infection is actively altering hormonal balance as it progresses, rather than high testosterone individuals simply being more prone to exposure, which could also be true. We just don't know yet. Another dimension is that testosterone interacts with neurotransmitters like dopamine and serotonin by increasing their production. These neurotransmitters play a key role in regulating emotions, and so infection with Toxoplasma gondii may actually make you happier. Higher testosterone in men could, in theory, counteract part of the observed decline in global average levels, a decline that is worryingly steep of around 1% per year over the past few decades. Reduced testosterone in men can lead to decreased muscle mass, erectile dysfunction, lower fertility, and a higher risk of depression, irritability, low mood, poor concentration, and memory problems alongside much more. So clearly this is something you want to avoid. An increase in testosterone has also been observed in women. This might sound concerning, but levels in infected women remain within the normal physiological range. Women naturally produce testosterone, in smaller amounts than men of course, and convert it into estrogens, which are essential to maintaining reproductive functions, so it does not seem to do any harm in this respect. That means it is unlikely to cause health problems that people usually associate with hormonal changes in women. Now for something completely unexpected. Infection could make male faces more attractive. One 2013 study found that infected men rated by women as more dominant, had more symmetrical faces, and somewhat surprisingly, were taller by an average of 3 centimeters. Why might this be? One possibility is that increased testosterone levels during key developmental periods could influence not only behavioral traits like risk-taking and competitiveness, but also physical traits such as growth and facial symmetry. Higher prenatal or adolescent testosterone exposure is linked to increased height and more masculine facial features. It might also explain why infected men showed different digit ratios, which are thought to reflect prenatal hormonal exposure. So it seems, in this respect at least, infection might have some upsides. To investigate this further, researchers designed a rather simple experiment. They infected rats with Toxoplasma gondii and then set up tests that encouraged the animals to make a choice involving risk. In this setup, rats could increasingly inflate a balloon to earn an increasingly larger reward. But with every pump, the chance the balloon would pop would increase. This would mean that the rat would lose its reward. They found that the infected rats were more willing to tolerate the potential risk of losing their reward in pursuit of a greater one when compared to uninfected rats. In another research condition, researchers artificially boosted testosterone in healthy uninfected rats, and the same behaviour emerged. This finding is very important, as these results seem to suggest that Toxoplasma gondii is manipulating hormonal systems specifically to increase risk tolerance, meaning that many of the other effects we discussed previously and will discuss later on, for want of a better way of putting it, are unintended side effects, or at the very least are not actively harmful to the parasite. Of course, a single-celled organism cannot have intentions. That implies the ability to consciously make choices, which is far too simple to do. The main benefit to the parasite, and likely why this hormonal manipulation has evolved in the first place, is to reduce the fear response in the cat's prey animals, and therefore making them more likely to wander into the path of a hungry cat, meaning the parasite can complete its life cycle once more. Now that we have established the most likely method of the parasite's behavioural manipulation, let's look at some other examples of how it can influence our behaviour. Multiple studies have found that people infected with Toxoplasma gondii are associated with higher scores on measures of impulsivity, sensation-seeking, and competitiveness. One study sought to find the real-world consequences of this by testing over 1,500 students for signs of past infection and compared their results with career-related data. What they found was surprising. Those who tested positive were 1.4 times more likely to be business majors, and even more surprising, they were 1.8 times more likely to have started their own business. Another, much larger scale study examined the medical and professional histories of 74,291 Danish women. They discovered that those infected with the parasite were, on average, 29% more likely than others to have founded a startup company, 27% more likely to have founded multiple ventures, and more than twice as likely to have founded their business alone. That's a rather substantial difference. At first glance, this seems absurd. How could a single-celled organism have such a noticeable effect on something as complex as starting a business? Well, because inside its genetic code, Toxoplasma gondii carries genes that resemble those used to make the enzyme called tyrosine hydroxylase. That enzyme plays a critical role in dopamine synthesis. Dopamine is not only involved in our brain's reward systems, but also in motivation, reward prediction, learning, and the pursuit of goals. Do not forget about the fact that testosterone, which the parasite also increases dopamine production. If the parasite is boosting dopamine in the brain, the knock-on effects could be significant. More drive, more confidence, more willingness to take calculated risks. From the parasite's point of view, all this is about increasing the chance that the host will behave in ways that will bring it back to the cat, but from our point of view, it's tempting to see a certain upside. If you're a man, it can make you more attractive. For both men and women, it can make us happier and more successful, but it does have a darker side. Some research finds that infected individuals have longer reaction times, which means they respond more slowly. This reduced reaction time seems to be the cause of the relationship between infection and greater risk of traffic accidents. One review of 9 studies examining the trend concluded Toxoplasma gondii significantly increases the risk of having traffic accidents. There is also evidence linking it to mental health conditions such as schizophrenia, possibly through its influence on the dopamine pathways and inflammatory response in the brain. Dysregulation of dopamine signaling is a consistent finding in schizophrenia research. However, toxoplasmosis should be viewed as a risk factor, as many other factors come into play, and it is very unlikely to be the sole cause of the development of the condition. It has also been found to be associated with higher likelihood that a person attempts to end their own life, which is clearly not very good for us. Some studies even suggest it can affect immune signaling in ways that might influence long-term health, including heart disease risk, though that research is still in its infancy. So yes, there are intriguing and even surprising correlations between Toxoplasma gondii infection and certain high achievement traits, but there are also equally strong associations with dangerous, unpredictable, and potentially life-threatening outcomes. Remember, this is an organism that has evolved with a single goal, completing its life cycle. And if that means subtly tweaking your brain chemistry to serve its ends, it will. Maybe you're infected and the parasite has helped you. Maybe it has harmed you. Maybe you aren't infected at all. The vast majority of people go their whole lives without knowing that a parasite is in their head and subtly influencing their decisions. At least, thanks to this video, you now know that it could be the case. Either way, stay safe out there. And as always, thank you for watching, and goodbye.